Welcome to Investigation 3.1, Solving Linear Equations. In this one, we are going to be looking at selling greeting cards. So Acquire is going to be selling some greeting cards, and we're going to be looking at some properties that are associated with that. First things first, before we get started, though, we need to add a word to our words worth knowing. We have properties of equality. Properties of equality are essentially things that you have learned in Moving Straight Ahead from 7th grade. And what you will find is that you essentially can add or subtract to find equivalent expressions. And then the other part of this is we can also multiply or divide to find equivalent expressions. So we can do a couple of different things. We can add or subtract, which are opposite operations, add or subtract, or we can multiply or divide to find equivalent equations. So let's use that exact concept for this particular problem. We have 100 plus 4x is equal to 25 plus 7x. So we can use our addition and subtraction and multiplication and division to sort of balance this equation out. I'm going to draw a big, huge line through the middle of it to show that whatever I do on one side needs to happen on the other side as well. So we are going to first subtract 4x from both sides. Why did I choose to do that? It doesn't quite matter so much, but at the same time, I know that I would like to get my variables on one side of the equation. So if I were to do that, I find that if I subtract 4x, because I currently have 4x being added, if I subtract it, it'll bring that 4x to 0, but then also we have our 7x will be balanced with it, so we get 3x on this other side. So we can finish writing this equation as saying 25 plus 3x is equal to 100, because 4x minus 4x gets me 0. Then after that, I can start to get my x by itself. We want to get that all by itself, so I'm going to subtract 25 from both sides. 100 minus 25 equals 75. There's my equal sign. 25 minus 25 equals 0, so that gets left behind. And my 3x is going to come down to here. Very last thing, I see that I have 3x, which is also written as 3 times x, so we could divide by 3 on both sides. So 75 divided by 3 gets me 25, and that is equal to x. So I just used some properties of equality to balance this equation. I subtracted when I saw addition, and I divided when I saw multiplication. So I balanced things. I continued to find equivalent expressions. Using this idea, we're going to tackle this problem. So here's our problem. We have the profit of a choir company, or a choir selling greeting cards. So here's the sales from greeting cards is modeled by this equation. So the profit is equal to 5s minus 100 plus 2s. So understanding what is occurring here in this equation is important. So we know our profit is P and S is sales, so that works for two parts of this equation. But this 5 is representing making of $5 per box of cards, and then this 2 represents paying $2 with each box. And then they also have a flat rate that they have to pay no matter what to this company. So if they only sell 2 boxes, they still have to pay $100 to even be able to sell their greeting cards. If they sell 1,000 boxes, thank goodness they're starting to make some profit, but they still have to pay that $100 in greeting cards. So using this information, let's actually find when the profit is $200, which is A2 in this problem. So we have $200 is equal to 5s minus 100 plus 2s. So let's do a little bit of math. If I look at this, I have 200 is equal to 5s, and I'm going to rewrite this subtraction. I'm going to write this as plus a negative 100 plus 2s. And if I write it as plus a negative, I need to figure out what number is hiding there. The only number that can really hide without really changing an equation is either 0 or 1. If it's multiplying something, it has to be 1. If it were 0, it'd turn everything else that it's multiplying into 0. So all of this wouldn't matter. And we want that to matter. It makes a difference. So we have now 200 is equal to 5s plus a negative 1 times 100 plus 2s. And that negative 1 is going to distribute into this 100 and the 2s, so we'll finally end up with 200 is equal to 5s plus a negative 100 plus a negative 2s. Another way I can write this is I can simplify this a little bit. So I have 200 is equal to 3s, 5s plus a negative 2s, plus a negative 100. I can add 100 to each side, plus 100. So we end up getting 300 is equal to 3s, s, divide by 3. Notice I'm using the properties of equality, and I get simply 100 boxes need to be sold to make a $200 profit. So really not a lot of money is being made as of right now. But 100 boxes are being sold to make a $200 profit. I'll add boxes to this. So using this information and knowing that we can do this, is there another equivalent form of this equation? Could we write this in a simpler way? So I'm going to rewrite our equation. We have P is equal to 5s minus 100 plus 2s. An equivalent form of this particular equation could be noticing that when we did this, I played around with this 5s and I played around with this 2s, and I combined those. I simplified them. The only way I could do that is saying, well, this is really plus a negative 1. So we could rewrite this as saying plus a negative 1 and multiplying this through, distributing it through. So we end up getting 5s plus a negative 100 plus a negative 2s. And then from there, we can combine those two. So an equivalent form of this particular equation, we could say the profit was equal to 3 times the number of $3 for each box sold minus 100. So essentially, we are finding ourselves a linear equation that works, oh goodness, I'm making a mess, that works with this particular problem. 100 is added to it. Play around with this equation. Your job is to do A through C, and also understand that we have this properties of equality that we need to pay attention to. But use those two things to work through investigation 3.1, A through C, and then also the homework problems that are attached to it. Enjoy, and as always, be sure to email me or text me or call me if you have any questions. Thanks so much. Bye.